Okay, hello again, everyone. As I mentioned, we're going to be working on some data access layer logic here. First things first, I want to import this SQLx package. If you're not already familiar with it, it basically just allows you to reduce any boilerplate related to mapping your database result set rows into your structs, but it still allows you to write raw SQL. It's a very popular package as well. And it's pretty battle tested, and I've used it several times and like it quite a bit. So let's go ahead and install that. Okay, so now in the store here, I'm going to create a users file, and I'm going to create a user store. I don't need an extra S there, actually. This is just going to be a struct that contains a reference to the SQLx database. And I am going to create a constructor that accepts a standard library SQL database and then convert that into a SQLx database, just to keep this package isolated to, or keep the SQLx library isolated to this store package as much as possible. So let's do func new user store. We're going to pass in a regular SQL DB. And then we're going to return a DB, and then it'll be SQLx.newDB. And we have to pass in the driver name. I do need to import libpq again, since we're referencing that driver here. I don't know why Go does this, by the way, like these magical import side effect things. It's really weird. But to summarize the things that we need to implement for this data access layer, we need to be able to create a user. So we will do user store, create user. We'll pass in a context. If you watched one of my previous videos, which if you haven't watched it, go watch it. You always want to provide a context when you're querying your database, or as a best practice, you should do this. And if you don't know why, go check out that video. I'll link it. And what we're going to do is accept some user parameters. But first, I'm getting ahead of myself. Let's create our user type. So we've got a user. We need to have an ID, which is a UUID. One more thing. I'm going to import the Google UUID package. So let me do that. Okay. All right, we've got this DB tag here is a helper annotation that basically helps us map the column to the struct name. So similar to the other library that we used to load environment variables into the config struct, we're doing the same thing here with a SQL result set into a struct. So that's what these annotations do here. I believe we had email, string, DB email, we had password. This is going to be hashed password. We're not going to store the user's password at all in a plain text format. And really, it's going to be base64 encoded as well. So let's annotate that there, base64 hashed password. Actually, I like to add that as the suffix. That seems a little bit easier to read. And we're going to have a created at, of course. Created at will not be nil because we should always have that value. Okay, so now we can create a user. What we're going to do is prepare our SQL statement. So first, let's do SQL is equal to insert into users. Got most of this here actually. Insert into users, the email, hashed password, values, and then we want to return star. Two of these columns are going to be auto-generated for us as part of our data definition language. Let's take a look at that again. We've got the ID, which is the primary key. It's a UUID. We're not providing that. It's going to be generated by this Postgres function. We are providing the email and the hashed password. And created at is not going to be provided by us. It'll be generated by default on record creation as well. So we're going to return star here, and then we're going to declare the user variable that we're going to be populating. What we need to do is use the SQLx DB object, and we're going to do a get context. And what this does is it just executes a SQL statement that's querying some data, and it's going to populate. We basically provide a struct or some interface that will be mapped to the result set. So that's what we're doing here. We're going to pass in the SQL statement. Actually, let me do SQL. Let's call this DML, data manipulation language. And we're going to pass in a email and hash password. Actually, the password that we're going to be receiving as an argument is actually going to be in plain text at this time. So this will just be password. And it will be a string. And what we actually need to do is first convert that string into a hashed version that then gets base 64 encoded before we store it into the database. So let's go ahead and import another library, which is bcrypt. And I'm actually going to steal from this Go web examples. It's got pretty good stuff. So I'm going to go ahead and get this package. Okay. And I'm going to hash the password here. Bytes bcrypt. We're hashing it into bytes. The cost, I think we can use a constant here. Bcrypt min cost. What about default cost? That seems good to me. I don't really know the difference. I don't know if it matters for this video. Let's do fump.aref, fail to hash password. Okay, so we've got the password here as bytes. Now let's get it as hashed password base 64 is equal to base 64. Standard encoding, encode to string. This is pretty common stuff, but it's just imported from this encoding package here. And so now we have a string representation, a base 64 string representation of these bytes that we can store in the database column itself. So we've got email and then hashed password base 64. I'm going to check the error. Failed to insert user. Looks good to me. We'll return the user and boom. So we accept an email password. We create a hash of the password, and then we're storing that instead in the database. And then it's got some handy, this package has some handy helper methods here, so we can actually compare the hash and the plain text password. So let's go ahead and add a method to our user object so that we can do that. Oops, let's do this. We want to do u. If I can type. Wow, okay. Oops. This all looks good. I'm just going to paste this in. We're going to compare these. So what we need to do is get the byte version of the base64 password that's on this struct here. So let's do base64.standardencoding.decode string. We can decode this and it should give us back some bytes, which is good. Error. If the error is not equal to nil, we'll return that. And we are going to compare the hash, which we already have, and the plaintext password here. So if error is not equal to nil, we can say return from .ref invalid password. Cool. So we can use this at a later point, but I wanted to go ahead and just get this written since we are getting familiar with this package here. So there may be some tweaks we need to make, but in general, we'll be comparing the bytes of the hashed password to the bytes of the plaintext password provided, and this will handle it for us. So that makes it pretty simple. It's only a couple lines of code there. Okay. Next thing we need to do is be able to retrieve a user by ID and probably email as well. So we'll just make 2 extra helper methods. Find user by email. I like to just do by email here. We're of course going to provide the context. We are also going to provide the email that we're looking up the user, or that we're using to look up the user rather. So query is going to be select star from users where email is equal to that. That looks good to me. And we're just going to do very similar code to this get context. If get context, provide the context, the user that we're populating, the query, and then the argument. So that looks good to me. Failed to fetch user, and we're going to return the address of the user and nil. We're going to basically copy and paste this and change it to be the user ID, because we'll want to have both of these. This will be a UUID. Whoops, what am I doing? It's going to be user ID. Okay, where ID equals this. Okay, cool. So we've got 4 helper methods written. I haven't tested any of this. It's okay. We're going to do that next. So I'm going to go ahead and set this up so that we can test it in a unit test. The first thing I want to do, though, is make some slight modifications to the Docker Compose setup. What I actually want to do is have a separate database instance or database container running on a different port so that my development environment and my test environment can be completely separate. I've also got this volume set up for my development database, and I don't really care about persisting any of the information in the test environment outside of the process. So if the container restarts, I actually want the data to be cleared. So I'm going to create another thing here. I'm going to copy most of this. This is DB. It's going to be test DB. And all of this is going to be the same, except the port here is going to be mapped to 5433 instead of 5432. And I'm also going to make one more variable for this. So let's do export DB port test equals 5433. This is going to be DB port test. I also want to import this into my config here because I'm going to do something slightly hacky, but I think it's totally fine for what we're doing here. So database port test, string env database port test. And I actually want to override the port if we're in a test environment. So I'm going to have to make some additional changes to our configs as well. I'm going to introduce the concept of environments. So I'm going to have a test environment and a dev environment. And then eventually when this, would be deployed, you'd have a production environment. So what we're going to do is have port equal to database port, and then we'll say if, let's do something like type env, it's a string, and const env test, env equals to test. We can make this lowercase, doesn't matter. Env dev is equal to dev. And we're also going to store this as a member on our config. So let's say env is equal to env. Default will be dev. And so if this environment variable is not set, we're defaulting to the dev environment. And then when we run unit tests, I'm actually going to override this environment variable to be test. So now what we're going to do is in our database URL construction, I'm going to say if the env, if c.env is equal to test, then port is going to be the test database port. And now we can use that here instead. And as I mentioned, it's not super pretty. It's a little hacky, but it actually works quite well for unit testing because I don't have to mess with conflicting environments and things like that. Okay. So what I want to do now is create some sort of unit test that I can just go ahead and test all of these helpers that I just created. So we'll say users test.go. Okay. We'll say func test users user store testing.t. And for now, maybe I just create the database connection here. Let's say, actually I need to create a config first. Let's say config error is equal to config dot new. And now that I'm writing a unit test, I realized, oh, there's another package that I want to use, and it's the testify package that allows me to do one-liner assertions and things like that. So I think it'll auto import that for me. Require no error here. No? Okay, let's do this. Testify. Golang. Go get. There we go. Boom. Go get stretcher testify. Okay. So now I can assert that the config loaded successfully and that there was no error, but it's not going to know that the environment was overridden. So I'm going to have to do this first. Set env. The key will be env, and then config dot environment test. Okay. So now this should load the correct database URL when I prepare that. So db error is going to be new Postgres DB. Okay. Require no error. Defer DB close, that's fine. Something else I'm going to need to do is provision our database tables. So this is going to be a new database container, and the migration is not going to be persisted each time. So we're going to have to use the migrate Go library to run our migration to set up our tables for the unit test. So let's go check that out. We are here. I want to go back and find the Go code here. Migrate new. This looks like what I want. But I forgot I need to go ahead and import all of these things. So go get source URL in this case is just going to be, I think, file migrations. This just has to be the directory where my migrations are stored. And then this will be the database URL, which we have from the config. Okay, so this creates a migration object, a migrate object, and an error. So we will require that there's no error. And what we want to do is do im.up. If error is equal to im up, error not equal to nil, and error is not equal to error no change, then we'll require error. So this library will actually throw an error when this migrate up method is called if there was no database change. So if for some reason it was ran twice, I think it would cause an error. So we're going to explicitly check for this particular error and say, if it's not that, then we can fail this test. Okay, so what this should do is set up our database tables, and then we should be able to execute our user store code. So let's create our user store. It's equal to new user store. And let's do this. Let's say user store.create user. Context.background. Email is going to be test@test.com. Password is going to be testing password. Okay, so we'll have a user, an error. We should require that there's no error here. And I've just realized that I've written a lot of code already, but we're very close to having like a pretty solid initial unit test here. So I'll just go ahead and write the next couple lines, and then we'll go ahead and run this. So require equal. I want the returned user to ensure that it has that email and that I can compare the password and verify that the hashed version would match this. Require equal, require no error. T, let's say user.compare password. So the basics, once this is hashed, it should match the hashed password that is persisted in the database. Okay, so this should work initially. So we can try this out and see what fails. Stretcher, blah, blah, blah. Maybe I need to do go mod tidy. Failed to ping database. So let me do I'm going to restart the Docker Compose process so that it spins up both databases now, because I don't think I did that before. Okay, so now we can see the test DB is running. DB is running as well. I just want to make sure that all the credentials should be the same except the port is different. So we are overriding the port here if the environment variable is overridden, and we are doing that in the test itself at the top. So we're overriding the environment variable, then creating the config, then creating the database from that, running our migration to set up the tables, and then making our assertions against the data access layer helpers that we just wrote. So let's see if this works. That's annoying. Let's do this. Let's funct.printf. Okay, so none of these environment variables are being loaded. Enable dir env. Okay, so we were getting an issue originally where the environment variables weren't loaded. This was a issue with my runtime configuration or my test run configuration. It wasn't picking up dir env. I've got that fixed, but now we are getting this issue with the migrations directory. I believe I'm just missing a package here, which is this one. Got some other magic import here. Nice. Okay, let's try this again. I'm gonna do something else here. Export project root equals. Okay, project root, we've got that. I'm gonna go back to the config. Okay, so now in the test, I'm going to say funct.sprintf file. Okay, cool. So we can see that this actually ran and succeeded now. And what happened was I was just missing. First issue was I was not correctly loading environment variables into my test configuration. I just checked a box that allowed dir env to load in my test environment, and that started working. And then I was missing these few imports. This is working, but I don't want to do these steps for every test. So what I'm actually going to do is create a test fixture that makes this easier and a lot cleaner to run for every test. And in addition to this, I want to be able to clean up my database after each test. So I'm going to create a fixtures directory. And I'll just create a sort of test environment that allows me to set all this up automatically, or a lot easier. So I'm going to create a test env. I'm going to have a reference to the database. And that should be fine for now. We'll start with this. Func new test env. We will have the database nil for now. And what I'm going to do is pass in a context. Actually, let's pass in the testing object there. And I'm going to pass in the app config. Okay, so we've got this testing object. There's a few things I'm going to need. I'm also going to need the config here. I'll keep a reference to that anyway, because I'm going to need this for almost every test. I'm going to need the database for a lot of my tests. And you'll notice here I'm writing integration tests against the database. I personally like doing that, and it makes me feel a lot more confident in the code that I've written, especially something as important as storing data. So what we're going to do is get our config prepared, require no error here. First things first, let's override that environment. Variable here, config.envtest. We're overriding it. Slightly annoying doing that. Let's load the config here. Let's do the DB. Okay. So now we've got the config created, we've got the database connection created. Let's provide those to this test environment. And we should be good to go here. The other thing I want to implement here is the migration logic. I'm going to do that separately in a separate method that I can call it as needed. So let's call this test environment, test env. Let's do setup db. And here, I'm going to copy over all that migration logic here. Okay. We've got te.config, te.config. I want to pass in the testing object as well. So I can pretty much mimic all of this stuff. Okay. What I also want to do is return a function that reminds me that I need to clean up my database after each test. So I don't want to just spin up these resources and then not tear them down, so that I don't have to worry about any conflicts between tests. So what I'm going to do is add a helper that cleans up the database as well. Tear down DB. Let's do DB close. I don't really care about that for now. I want to do TE db.exec. I want to do truncate table. And what I'm actually going to do is just do something interesting here, which is provide a slice of the tables all at once and join them with a comma so that it's a comma separated list. And this will truncate all of them at once, and this avoids weird issues that may occur due to foreign key constraints and things like that. Tokens. The last table was reports. I actually might want to call that reports jobs, but we'll worry about that later. DB exec will execute this query. Error, let's say require no error. So we'll truncate table, strings.join. Okay, so we'll truncate all these tables at the same time. Something else I want to return is this method here. So it's te.teardown db. Okay, so I'm just going to return this method here from the setup so that I have a reminder to tear down the database each time. All right, so what I'm going to do is actually comment all this out. And I'm going to create my test environment. Pass in the T there, and we've got env.setupdb. And it returns a, actually it's probably best practice to do t.cleanup like this. And this is the teardown method that we created. Here I can easily access the database object, and this can all be cleaned up. And now I can reuse all of this code, this setup, for all of my dependencies that I may need. And that keeps it a lot easier. You may run into problems as you add a lot more dependencies and as you scale, but it's not a huge deal, I think. Okay. So we've got create user tested. I want to do user store dot by ID, and let's see, it should be I'm going to create one context and reuse it. This will be the user ID we just created. Require equal, let's say user1.email is equal to user2.email. Require.equal user1.id is equal to user2.id. Require.equal t user passwords are equal. And something else I wanted to make sure is that we also verified that the created at timestamp is created. So let's just say now. Time.now and dot I'm just making sure that this timestamp is before the created at timestamp, which this should work for nanoseconds, hopefully. And then I also want to make sure that these are equal. Maybe this is overkill, but whatever. Oh, man. Fixtures. What did I do here? Okay, apologies. My camera overheated, so I had to cut the video short for a minute. But it turns out that circular import error is due to the fact that I was not using an underscore test package here. So normally I will do an underscore test package, and that is generally good practice because I'm actually testing the API that I'm exposing from the package that I'm testing. So I generally want to do that anyway, but that resolved the issue that I was experiencing. And there was one more thing I wanted to do before I closed out this unit test is test out the by email method that we created, and it's going to basically be the exact same thing that we have here. So I'm just going to copy and paste user2 by email, user.email, and I'll reassign that user2 variable, keep all the same assertions, and rerun this test to make sure everything's working still. And it does, so we're in good shape there. This is a good stopping point for this video. We went over setting up the user store, modifying the Docker containers with Docker Compose to make sure that we can have a test container running, and we made sure that our test fixtures are all set up so that we can cleanly set up and clean up our database each time. So I think in the next video I might jump into some API server development. I don't think I'll complete all of the data model work quite yet until we need it at a later point. So I will see you guys in the next one. Take care.